Hello, and welcome to another episode of Risky Business. Today, we are going to continue our uh, dive into the world of Milton's rendering stuff. So, yesterday we covered a lot of it, but we still want to look at GPU cook stroke, and I think there was like a push call or something that we want to look at. And I think then we're going to find some good OpenGL documentation to reference and maybe start whiteboarding out our plans a little bit. So let's dive into this. So GPU cook stroke. So I'm not sure what he means by cooked. I guess rendered rather than just like stored internally as a stroke. Because this is like using vectors, even though it looks like a raster based kind of thing. It's actually using vectors. So presumably cooked just means rasterizing the vector. So I was thinking, well, this is interesting that it can get recursive here. But I was thinking yesterday that this was going to be doing clipping and like not rendering outside of the screen, but now I'm thinking what he meant by clipping is like getting rid of that stuff that's far away, just picking what to render that's local to where you're working. And then the cook stroke is like it's rendering all this stuff. And it doesn't matter if you're rendering outside of the visible area. So I'm not going to worry too much about the algorithm that's happening here with the recursion and all that. I'm just going to assume it's good. We don't really care about the details of rasterizing a stroke, because that's not what we're messing with. So it does some shader stuff. It does some memory stuff. It does some mathy stuff. It does some geometry stuff. It does some more mathy stuff. It handles pressure. And here we're doing OpenGL stuff. So I guess here we're actually rendering the stroke. Okay, so I think that's all I really wanted to look at for that. Now, I need to remember why I was looking at that. Where were we that we were looking at that? Was it this? Yeah, this is the clipping stuff right here, isn't it? Yeah. So I saw after we did the cook stroke, there was this push clip array thing. So I guess push is just like a generic pushing operation. And then this is the array we're pushing onto. And this is what we're pushing. So I don't think we need to take a look at that. So now I wonder, when we're rendering, are we going to want to do it in clip strokes and update? The high-level description of this is create OpenGL objects for strokes that are in view but are not loaded on the GPU, deletes content for strokes that are far away. So this is really just for strokes. So I think we don't want to do that. I think we want to do our work in like GPU render canvas or something like that. One of the GPU render functions is where we're going to be messing around. So I think I want to take a moment now and start actually, let's look some stuff up. Oh, and I should mention, here's just a unrelated thing. I have a poll up on HMN_risky on Twitter, which is where you can follow updates for when I stream. I always post like an hour before I start streaming. The YouTube videos automatically go up on there. I post a schedule at the beginning of the week. I post if I'm not streaming. But here's a poll that I posted. It's currently pinned to the top of the page. So, should Risky Business have a private GitHub repo? And actually, I don't mean repo. I mean organization. Or should it be free to the public? So if it's private, it would be available to people who back the series on Patreon. I'm not trying to push this on people, which is why I made a poll. Because I'm just doing this out of, like, I feel like it's important and I care about it. And, you know, I want to do something about this. So that's why I'm doing Risky Business. It's kind of an altruistic thing, right? So I'm not in it to make money, but it has cost a lot of money to get this set up. So it would be nice if I could, you know, like, get a little bit of financial help in running this series. But like I say, I'm not forcing that on people. I'm not trying to, like, push that. But it does seem like a reasonable thing to do, to have a private repo. Like, that's what handmade-hero does. And, like, 4Coder, you pay to get access. You know, you back it on Patreon and then you get access to builds and stuff. It seems like a reasonable model. So, and I think it would encourage people to help support the series. But otherwise, like, originally I was thinking I'll just make it public. And I know people would appreciate that who either can't financially support the series or simply don't want to. So far it has 0 votes. There's 3 days left on it. So I encourage people to vote on this because I'm going to go with whatever the popular vote is. If there is no popular vote, if no one votes on this, I'm going to make it private for Patreon backers. So if you care about this, so I should say the GitHub repo is going to have things like any coding we do on the series, basically. So all the projects we do that are software related for risc-v related stuff is going to go in that GitHub organization. And like right now we're going to be implementing Milton custom features for the series that would go on the organization. So like basically anything we do on the series. So if you care about that, if you want to mess with the code, please vote on this, because I want to know what the people want. You know, do you just want it to be public, or do you think it's okay to have it be private and support the series that way? So yeah, please vote on this. It's got 0 votes so far. So anyway, back to what we were saying. I want to find some OpenGL reference. And I know there are good OpenGL references out there. I was studying OpenGL at one time, but I stopped to do the series instead. So I know there are good sites for OpenGL references, but I don't remember what they are. So if anyone in the chat knows, I know Popcorn, I see you're possibly watching. If you know any OpenGL references that are good, paste a link in the chat. Or if anyone else is watching, please let me know, because I don't remember what the OpenGL reference was. I remember there was this really nice site that had like all the different versions of OpenGL. And like it was a really good reference. But I don't remember what it was. All the versions. I don't think it was like an official reference that I'm thinking of. I guess I also don't know what what version of OpenGL we're supporting. Let's just assume OpenGL 3 or something. So yeah, this is the official documentation. That's not what I'm thinking of. I mean, if nothing else, we can use it. But I feel like there's something better. Oh, thank you, Popcorn. I hope someone on IRC knows what I'm talking about. Good OpenGL reference site. Let's check. I think Reddit has like a subreddit on OpenGL. They might have a like links to resources. Reddit OpenGL. So OpenGL wiki, official reference, docs.gl. I think that's what I'm thinking of. API tables, some database thing. Yeah, docs.gl. This is what I was thinking of. So you can search stuff. It has the commands. It tells you what it's available in. I think that's a nice reference. So we are going to use docs.gl as our OpenGL reference. Anyway, now I think we're going to do some whiteboarding. So let me open up the stream thing. So I want to kind of just whiteboard out everything I'm thinking about how we're going to implement this. Now I wonder if there's a... Yeah, it looks like my microphone can go in far enough that I don't need to push it away while I'm drawing, that is. So the first thing is we have this canvas to raster conversion, and I've done things like this before in my own work, so I'm kind of familiar with this. It's always confusing to me, coordinate conversion stuff. I'm not good at this, so I'm gonna whiteboard it out and try to get an intuitive, picture of this coordinate conversion. So basically here, we have like, we're gonna say we have like an image here. And it also has a scale to it. So we're going to say like, let's draw a bigger rectangle. Here, let's try to make it like 2 times the size. On each axis, that is. So we're going to say like this is 2x scale. So these are the same thing. That's the idea here. Now, so these are views of the canvas, right? And now we're gonna say that like this is 0, 0 in canvas space. And now we're going to say that we have a window here. So what I'm drawing right now is the actual view that we're looking at. And so this is 0, 0, and now is this raster space what we're actually viewing? I'm gonna say it is, and we're gonna do the math and see what happens. So this, of course, is 0, 0, canvas. And we're going to say this is like in the center of this. So the canvas, of course, doesn't have like a width and a height properly, but for the sake of this, I'm just drawing it as like this finite image thing. But anyway, so this point right here is, we're going to call it P, and I think that refers to this right here. Or is that the pan vector? And then, of course, we have our center. So I'm trying to make sense of this. I'm thinking the pan vector would be like basically this vector right here. Right, and then because it's 2x, that's the scale. So, like, essentially what we're looking at here is, this is the 1x scale here. So, like, we're looking at this essentially, but it's blown up 2x. So instead of this vector that would go along here, it's this vector, so it's a longer pan vector is the difference with the scale. But the points P would be 0, 0 in raster space, if I'm understanding correctly. And in canvas space, if we're talking about it in the canvas space, then it would already have the pan vector added to it, because that's what it would be in canvas space, right? And then why are we adding the center to it? So I don't think my mental model is correct here. That doesn't, like, this isn't working out in my mind. This seems incorrect. So we're going to take a closer look at the code and try to get a better mental model of what the coordinate conversion is. So what was that? It was canvas canvas to raster. So first of all, let's like make a note of how it's actually called. So canvas to raster view and bbox dot top left. And this converts top left, the bbox.top left in canvas space to raster space. So converts bbox dot from canvas space to raster space. Now, this is an example of the actual use of this function. And I believe that's really going to help us. So where was canvas defined? Canvas.cc. And also I want to see what the view is. I want to see specifically what view is. So we're passing the canvas view in. So I want to take a look at the canvas view structure, I guess. So let's take a look at canvas.cc. Okay, so here's the actual definition of a canvas view. It has screen size in pixels, the zooms, which is scale, screen center in pixels, pan vector and canvas scale, so view contains so I'm just going to do like a little like pseudocode here and say this has pan vector scale center so this is in canvas scale. This is the zoom. This is screen center in pixels. So points is what we're passing in that we want to convert. So let's redo our diagram. So the thing we care about is in canvas space. So let's draw a canvas. And we're going to draw it kind of like this instead of a finite like image, we're going to represent the canvas as a space with two axes. And so this is the origin. And now we're going to say we want to know what, like, well, let's draw a view in this space first of all. So I'm going to put some markings here just so that we have a scale. And now let's say we have our view something like this. So now we're representing this view with a pan vector, a scale, and a screen center in pixels. So if the screen center is in pixels, that's talking about raster space, not canvas space, because the units of the canvas are not necessarily pixels on the screen because of the zoom. So basically what we have here is screen width screen height, and we need to know those basically for the raster conversion. But rather than representing them with a width and a height, we're representing them by the center, because we know this is this point right here is 0, 0 in raster space, right? And so if we have the center in pixels, that space, or that point right there, is going to be it's going to be 1/2 width, 1/2 height, in the raster space. And so that just gives us a waypoint that we can use for doing our conversion. So we have a pan vector, which would be this right here. And then we have a scale. So let's just say the scale is like scale equals 0.5, right? So it's like half the default size, okay? Our screen is half the default size. Or I mean, our view is half the default size. So now we're going to say, let's say we have a point in here, like right here. And we know the coordinates in the canvas space. So we're going to say our canvas space, the coordinates are 3 and 1, 2, 3, 4. Okay, so we just made up a point that we want to convert. So we know that the pan vector is two, 3. Now it's supposed to be in the canvas scale. So our scale is 0.5. Now I think the way I've drawn this, it's already in the canvas scale, I want to say. I'm not positive on that. But anyway, we're going to say well, here, let's make this concrete. So we're going to say that we're using like a 1920 display and Milton is in full screen and we don't have that top menu, right? Let's just make everything really simple and say we have 1920 by 1080 display area. So then center equals, excuse me, so our center will be half that. What's half 1920 and half 1080? I can never remember. And I'm not the best at mental math. 1920 divided by 2, 960. So it's going to be 960 by 540. 960, 540. I probably should have picked nicer numbers. It's going to be messy. So let me think here. Let's make a very contrived example where the numbers will work out nicely so that we can easily verify that we're right. So how many canvas units is this? This is like 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4. So it's 6 by 4. So we're going to say our screen is actually 12 by 8. So because it's 0.5 scale, it makes it 6x4 canvas units. So 12 by 8. Which means center equals 6/4 because it's half. Yeah, that should be right. So now we want to know what the value of the point at 3, 4 in canvas space is. We have a pan vector of 2, 3, and our center in pixels is 6, 4, because it's only a 12 by 8 screen. I know that's very contrived, but the numbers work out nicely for our little diagram here. So in that case, we say the pan vector, which is 2, 3, plus the point, which is 3, 4, equals 5, 7. So if we were to draw 5, 7, that would be like down here somewhere, right? But we need to divide it by the scale. So then we say divide but that's gonna make it bigger, isn't it? Because we're dividing by 0.5. So divide by 0.5, which would be 10, 14, wouldn't it? Because if you divide by 0.5, you're multiplying by 2. So equals 10, 14. And then we add the center, which is 6, 4. So we clearly did something wrong, didn't we? Because we're trying to find that point's value in raster space, and we're completely off the raster, right? The screen is like only 12 by 8, and we're at 16, 18. So that seems very wrong. Intuitively, the answer would be, let me see here. So if this center point is 6, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So right now the center is at 5, 5, right? 1, 2, 3, 4, 5. Looks like the center is at 5, 5, but its actual value is 6, 4. And our point here is somewhere over here, right? The point is at 3, 4. Now, is that exactly in the center? 1, 2, 3, 4, 5. So it's in the center between the origin and the center of the screen. Is it on this axis? So okay, we start here. That's 1, 2, 3. So we're starting here. So if it was in the center, it's a little bit off from the center on this axis. But we know that the correct, we can find easily the correct value for the y-axis at least. So we know that the y-axis, the value in canvas space is 1, 2, 3, 4, right? So p equals 3, 4. So its value is 4. And it is halfway between the origin and the center for the screen. So the screen is 12 by 8 in our little contrived example here. So 8, so the center is 6, 4, so this is 4, which means this is 2. So P should equals something 2 in raster space. And that something value is like less than 2. So something is wrong here. I think it's probably because we didn't change the scale of the pan vector when we said the pan vector is 2, 3. So do we divide that? We've got to divide it, right? Or I mean, the scale is 0.5. So we multiply the pan vector that we have here, the 2, 3, by the scale, which is the same as dividing it by 2. So then we get 1 and 1.5. So does that make more sense when we plug that in? So it would be 4 and 5.5. And that would give, when we do this part here, dividing by 0.5, so I'm saying we have, instead of 5, 7, we have 4 and 5.5. So that's going to be 8 and 11, right? I think so. I'm not good at math. 11 or something. We're gonna call it 11. Let me calculate that. Yes, it's 11. Okay. So 811 would be our new value, and then we add the 6, 4. That's still going to be way off. So my mental model is still wrong. My mental model is still definitely wrong. Maybe when he says raster space, he doesn't mean screen space. Or maybe I'm working through the calculations wrong. I feel like raster space would be screen space because the screen is in pixels, and that's a raster, right? Hmm, hmm, hmm. And it makes sense that it would be the screen space as the raster space because we know that the center is the screen center in pixels. So where am I going wrong here? I'm almost out of time too, so we're not going to figure this out today. But we've got like 5 minutes to mull it over. So canvas to raster. Hmm. Maybe I'm thinking about this backwards. Like maybe the way I've drawn it in my diagram is the canvas has this fixed scale and the the screen is shrunk down. But maybe the way to think about this is the other way around. Maybe we want to like think of the screen as this fixed thing and the canvas as shrunk down or expanded, right? Like if we're zooming in, then we'd be blowing up the scale of the canvas space. But does it matter which way we think about it? Doesn't isn't it the same thing either way? Hmm. I want to work through it like we know what the value is supposed to be. Like we know where you draw on the screen in pixels if you have that point in canvas space. We know it's I didn't calculate the x, but we know the y is 2. Like we know that for sure. Because we have the pan vector, it's 2, 3. We have our screen size, we have the scale. Like we go through the intuitive thing and we get a value. So if we just write out the equation that we're doing intuitively to get the value and then compare that to the equation that Milton is using, maybe we'll get insight into where our mental model is wrong. But I believe we're going to have to call it a day, and we will continue this mystery and figure out where our where our mental model is wrong tomorrow. So thank you everyone who tuned in today. And as always, thank you everyone who watches on YouTube. You can get to the archive easily at risc-v. You can also follow updates on HMN_risky on Twitter. We have a poll going, which you should vote on. And I'll see you tomorrow. So stay risky, everyone.